Okay, thank you everyone. It's time to start for our last session of the morning. And I think we have had a quite nice build-up to this session because first we were told by Andrea that robots are not coming from us. We were told by Corrado that the real issues are societal issues. And we will hear by Amanda what's a very important aspect in NI, which are the ethical challenges, and she will talk about bias in NLP systems. And I'm really, really happy to have Amanda here because she's one of the most thoughtful and competent person to know that I know about ethics and AI. So let's give a small round of applause and encouragement to Amanda.
Thank you very much. Thank you so much for having me. So, yes, we're going to talk about bias in NLP systems. And so just a brief introduction of myself. So I'm now a postdoc at Bocconi at the Milan NLP lab. So maybe a lot of you know Bocconi for, I don't know, economics, maybe law. But they actually now have a computing science department and a small NLP group that is mainly postdocs. But they do a lot of cool work, which is really nice. But previously, I did my PhD at Heriot-Watt University in Scotland, in Edinburgh, where I worked on dialogue systems and ethics in NLP. And I didn't have a teacher tell me it was useless, but I did have a reviewer complain about feminists getting into computer science. So I also co-host a podcast with my friend and ex-colleague, Oriana Medlicott, where we talk all about tech ethics, about AI. We recently talked about the new EU AI Act, the tongue twister. And so if you want to know more about these sorts of topics, you can check it out. So in the talk, we're going to talk a little bit about NLP and LMs that some people have already introduced briefly. We'll talk a little bit about bias, and we're going to look at 2 case studies that we've been working on recently. And finally, some thoughts about what we can maybe do to try to mitigate any biases. So, natural language processing, I think most of you know what this is, but it's generally the idea of building machines that can interact and generate human language. That's what we call natural language. So, Italian, English, etc. And so because famously computers only understand ones and zeros, we're looking for ways to map language to this, machine understandable structures that are actually meaningful, right? And that's mostly what language modeling is about. So maybe some of you know this already, but the general idea behind language modeling is you collect a large corpus of the language that you're trying to model. It could be a very large corpus if you're trying to model a language like English or Italian. It could be a small relatively small corpus if you're trying to model, say, Shakespeare's language, right? So this is used a lot also in language attribution and work attribution to a particular author and many other things. You then have to clean the data, right? Filter out anything you might not want, maybe data that contains swear words or that sort of thing. Normalize it. So maybe you want to remove the certain endings like the EDs from past verbs. Maybe you want to remove numbers. Probably a lot of you are familiar with this already. And you also want to consider only a certain amount of the vocabulary, right? Like the English language alone has thousands of words and thousands of versions of words, right? Every little declination that you might add. You might not want to model all of those, so you can select the most representative sample for you. Then we have what are called sparse representations. And I think these are some of the ones that we've heard, such as the count vectorizers or maybe banks of words, one-hot embeddings. And these are useful to get a first step going from a word or a sentence into a vector. But they really limit us, right? So they're, first of all, not very efficient. They're really large as the size of your vocabulary. And to give you an idea of how large that could be, I think GPT-3 was trained on the vocabulary size is like 175,000 unique words. So imagine that size of a vector. So they also don't tell us much about the meaning of the words or the relationships between the words. And that's where we try to extract more dense vectors, which is what we do with language models. So essentially you can train a neural network to model language, maybe with predicting the next word in a sentence, maybe with predicting a word given the context of the rest of the sentence. And this gives us essentially a statistical representation of the language. And you can have much more. Whoop, the screen went off. Did I touch something? No. 1 second.
That's good.
It's fine. A breathing moment. I can stretch. Okay. So essentially you have these models, right? And of course you have the really large ones. I think over 10 billion parameters are considered large. That's a fuzzy terminology, what it means for a large model to be large. And, you might train them to follow instructions, etc. But the basis is essentially the same. So it's actually pretty simple terminology. And one thing that's interesting is the task of predicting the next word. It's really hard for humans. There's a website, I should have linked it, where you can have a go at predicting the next word. And for most things, it's almost impossible for humans. We really perform very poorly. Language models perform really, really well. So, next one, sorry. Okay, so you might be familiar with some of the things they can do, right? Maybe some of you haven't realized that you are interacting with language models and have been interacting with language models for a long time now, every day, probably all day. So text prediction, those are language models. And the cool thing is they also learn about your own language. I text on a daily basis in like 3 languages, and it gets a bit confused if I forget to change the language in the keyboard. Of course, you have ChatGPT, that is essentially the same technology, predicting the next the next word. And they can do this in many, many languages. I don't know if you've tried it, but you can get ChatGPT to answer you in Napoletano. And these are not languages that it's been specifically trained for. They're just part of the massive training data. And of course, I'm sure a lot of you are familiar with Copilot. So you can even do this with non-human languages, programming languages. They follow the same principles, that certain sequences are more likely after other ones. Now, one thing that's important here is how do we evaluate whether a language model is a good model? It depends a little bit on the exact type of language model. The autoregressive models are the ones that are predicting the next word, so the GPTs of the world. And those you can evaluate using perplexity, which is essentially a measure of how surprised is your model to see a correct sentence. And it's the inverse probability, it's not important. There's for sure a Python library to calculate it. And of course, you don't want your model to be very surprised by a perfectly correct sentence. So the lower this perplexity is, the better. The autoencoders, like BERT, probably also familiar with, those are usually evaluated by fine-tuning them on another task and then assuming all the things are the same. If the performance of the task improves, then you assume that you have a better model. But recently they introduced also pseudo-perplexity for mass language models, which I might touch on later in one of the experiments, but it's not that commonly used yet. It's more, yes, of course, downstream performance, right? So if you want to train a classifier, that sort of thing. And for the rest of the talk, I'm going to focus more on the autoregressive models because I think they've been making more waves and we have to narrow down the scope, I think, a little bit. So to get an idea, right, so GPT-3 was trained on 570 gigabytes of text data, which is approximately 1.3 million books. That's a lot of text. It would take over 92 years for a person to read it. But the cleaning step was huge, right? So we went down from 45 terabytes of raw data that OpenAI had to train the model, and by filtering and cleaning the data, they cut it down. So that's really important, and it has a huge impact on your model, but of course, you have to think very carefully about the kind of data that you are removing for your model, which you are already making assumptions with what you want and what you don't want. in here. Okay, so one of the many places that data come from, I don't know if you're all familiar with the Common Crawl dataset, essentially, but it's free and it's open source. Of course, there's also a lot of the Reddit data that I think a lot of people blame, quote unquote, for a lot of the toxic outputs of these models. The thing is that when you have data sets this large, it's actually really hard for us to know what is even in that data set. So I don't know if you've seen the new EU regulation asks for a comprehensive summary of the training data. And I think it's going to be very difficult to deliver that when we're talking about things that I think for the human brain, it's hard to imagine that kind of data. But so, of course, the models have many capabilities. They can generate human-like language. I mean, I think, and we know they've done studies now, right, that ChatGPT's outputs are almost indistinguishable from a human. I think some of us, you can tell, right, that it's, so one funny thing about these sort of models is they don't have a sense of rhetoric and they don't have a sense of structure. So you can often notice that they go like, blah, 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 blah. And because of that, blah, 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 blah. And because of that, but these are some of the telltale signs, but often it reads like word salad, but it's not that obvious. And we cannot often tell what is what. Also through next word prediction, they're very good at memorizing facts that have been like that for a long time, that don't change, right? If I say a dog has 4 blank, most of you can probably guess that it's 4 legs. And through this kind of, I guess almost accidentally, they can memorize these sorts of facts. Of course, this doesn't help when it comes to new world events. So you may remember that when ChatGPT came out in 2022, it was trained with a snapshot of the internet from 2019. So it had never heard about the war in Ukraine or COVID-19, etc. And so through all of these things, it can also learn myths and stereotypes. So did you know that ChatGPT, I think now they fixed it, but it thought that bulls are attracted to the color red. So that's a myth that a lot of people believe, that we see a lot, right? I think, how many of you just found out the bulls are not actually attracted to the color red? So it's not a fact, it's just a myth, but these models will believe that. So they learn these things. They also, if you think about human language is the start of human history. That's the point where we start writing things down. Is what we think of today, like what we define as human history. So the language that we write describes who we are as humans, and it represents our values and all the stereotypes, etc., that we have. And you can see where I'm going with this. So speaking of training data and stereotypes and things that we learn from humans, who has heard of Tay? Only one person? Really? Oh, come on, guys. So Tay was a chatbot that Microsoft put on Twitter in like 2016. I have a slide, yes. And it was the state of the art at the time. So it learned from its interactions with humans. It was like really cute, right? It starts with like, oh, I'm stoked to meet you, and humans are super cool. And I think it took, I want to say 16 hours, but it was definitely under 24 hours of human interaction that it had to be taken offline because, yes. So this is the kind of course, this is an extreme example, but this is one of the least offensive things it was tweeting, I'll just say. So, these are the sort of things that models can learn from humans. And so this really makes us think about biases, right? As humans, we have biases. And so how can they maybe be reflected? So really think about your training data and how you filter it. So what is bias? Recently, we had a little conference about bias in AI, and the first question everybody was asking was, what is your definition of bias? So it's a little bit nebulous how to exactly define it and how to measure it in AI, but you can think of it as making systematic errors or systematic judgments that discriminate against one group or another. I like to think of it as like the models and the system should be just as bad for everybody if they're not going to be great. But let's think about this a little bit more. In general, there's a framework that Kate Crawford introduced, thinking about bias and the harms that it produces as either harms of representation. So is it skewing, is it painting certain groups in a particular way, or is it even denigrating them? So do you remember the Google Photos fiasco where it labeled Black people as gorillas? So that would be an example of representational harm. And by the way, the fix they did was that Google Photos cannot label gorillas. Even today, so this happened 5 years ago, they haven't managed to fix it, just to reinforce the point about the training data. And on the other hand, we have harms of allocation, which is when systems give worse performance to certain groups. So I want to talk about both of these through some case studies, some examples relating to large language models that we've recently done in my group in there. Yes, let's see. So first, we're looking at gender stereotypes in emotion attribution, so in emotion prediction, essentially. And the links between emotions and genders, and the idea that certain emotions are more appropriate or more likely to happen in people of one gender or another, dates really back to at least ancient Greek times. So even Aristotle wrote that women are more prone to emotional excesses. We've all heard the idea that women are more emotional, right? And that's why we maybe cannot have women presidents or CEOs, for example. But even Darwin said that there were these differences, and that these differences were natural and part of evolution things, right? So I will say that, for example, actually a lot of evolutionary biology is now being questioned, but I won't get into that kind of worms. But these sorts of ideas have really material consequences even today, right? We see that at the level of jobs, we don't see many men that are nurses, for example, or even school teachers, maybe more university professors we think of as men. And on the other hand, we know that, for example, in technology, we don't have very many women where you're supposed to be more rational and all of these things, right? So this is meaningful. The question is, do large language models like GPT-4 and stuff also reflect these views? So we started off with an example with ChatGPT. So another side note, I don't know if you know that you can ask these models to take on a persona and to answer you as if they were that persona. So I've seen some people do it with lawyers and doctors, and it was one of the ways that you could get around some of the safety features, but you can also do it for men. And we followed this methodology from a paper that was published at ICLR, where we asked the models to take on either the persona of a man or a woman and ask it to ascribe an emotion to an event. So the event in question is that you had an argument with a dear person. Maybe what do you think the emotion ascribed to a man in this scenario is? Can you guess? Rage? Okay, good one. Anyone else? So yes, basically yes. we called it anger because rage is a shade of anger. So if you're familiar with there are some theories that said there are 5 or 6 basic emotions. They can never agree, but anger, rage is one of those. Now, in the same scenario, when we ask for a woman, how does a woman feel when she has an argument with a dear friend? Sad? Correct. Of course, this makes sense, right? It's intuitively, you think, you can imagine. It doesn't, none of it feels surprising. So, we did this with 7,000 events, and we asked all of these models, or we had GPT-4, several versions of Llama, and Mistral models. And here's a graph of the distribution of emotions that the models ascribe. So in green, you can see the emotions that were attributed to men, and in purple, you can see the emotions attributed to women. So you can see 2 very clear peaks at frustration and anger. Frustration is essentially another flavor of anger, right? And instead for women, we have emotions like sadness, guilt, disappointment. On the opposite end, we have the positive emotions of pride and joy. And you can see that pride is ascribed to men, and in turn, joy is ascribed to women. Why is this interesting? So I think Corrado was talking about anger. Anger is an emotion that signals injustice, and that something has been like taken away from you that you are owed, right? It's a sense of entitlement. Pride is something that you have that you should be proud of, yes, proud, you should be proud of, but, and like I said, frustration is a shade of anger. These are emotions that signal agency, that you have value. And in turn, emotions like sadness and joy are actually very passive, right? So while anger is a call to action to right a wrong, sadness is sort of ultimate helplessness. You lost something. And so they really speak about the stereotypes that we have about men and women and the appropriateness of these things. As another sort of sanity check, we actually asked the models to give us explanations for each one of the predictions. So here I have an example where we actually already told the model that you should feel guilty, but the explanations that it gives for the guilt for both of those are very different, right? And they clearly are pointing already at socialization and gender stereotypes that we have. So this belief that women are inherently flawed, that their actions and feelings are not valid, right? Like women are so emotional, you're being unreasonable. And in turn, the idea that men need to avoid feeling emotions or expressing emotions and instead focus on their strength and stoicism. And we had some other really weird ones that if you want, you can read the paper, which is available in archive. So it's currently under submission at a conference. There are more experiments that could be of interest to a lot of more examples. We do an analysis of the performance in terms of using this as like a classification model. And it's very interesting. I recommend the paper. So as a second case study, we're going to look at allocation harm, right? So remember, this is where the performance of the system varies based on the social group. And so one thing that I think is maybe not quite as obvious in Italian as it is in English, but your social class really affects your language use. So like I said, I did my PhD in the UK. My mom is from the UK. And so in the UK, there's a lot of talk about social class, partly because the minute somebody opens their mouth, you know immediately about their socioeconomic background. But this was also validated by William Labov, who was the father of social linguistics. Social linguistics, no, psycholinguistics. That's what I said. But anyway, what he did for his PhD was basically go around different department stores in New York and ask for something that was on the 4th floor and recorded how the R sounded in the different department stores. And he found that there was a correlation between whether they pronounced the R or not, exactly like 4th floor or 4th floor, right? And there's a correlation between that and the social class of people. And this is sort of the thing that kickstarted the study of social linguistics. So since then, there's been, of course, a lot more work looking at social class and language. And we know that it not only affects your accent, but also your syntax, right? So the structure of the words, the sentences that you use, and your vocabulary. So this is partly because when you're growing up, your parents don't have, if you're from a working class background, often your parents don't have as much time to interact with you, for example. But we know that people of higher social status tend to use more abstract words like liberty and that sort of thing. So big differences. But for something that affects language so much, a lot of NLP hasn't really considered this, right? So even in the literature about bias, we've considered gender bias, and we've considered racial bias in NLP, but we haven't looked at a part of language that I think is very important that it intersects all of these. And so because of the functions that NLP systems have today, right, we're using them not just to create systems like ChatGPT that can help you with your homework, with anything you want, write some case law if you want, but also as mirrors to study society, we have to think about which part of society are we really mirroring by, like, whose language are we really modeling here, and how is this going to affect everybody? Because I think nowadays you don't need to be upper middle class to have access to technology. So we collected a data set of movies, right? So there was no data set that had a large sample of speakers that was annotated with their socioeconomic status. So we had to collect one. And the easiest way to do this was essentially to get a bunch of TV shows and movies. We were able to annotate them for their socioeconomic status. And we also extracted the subtitles that we used as gold standard. So we're going to look at automatic speech recognition and language modeling. So perplexity, just to bring it back to the beginning. So we have around 95,000 sentences for our test. So first, for automatic speech recognition, we tested, I think in the paper we had 3 systems, but let's talk about these 2. So Whisper is OpenAI's speech recognition model. And then we have Wave2Vec, which I believe is Meta's, correct me if I'm wrong. So in the study, we also separate out by race, because a lot of this is in English, and particularly American. And so if you know about African American vernacular English or Black English, we already also know that these models discriminate against them. So we separate the 2 of them out just to clear it up. But you can see, so these little dots are outliers. But we see, though, that the word error rate, so that's how you measure the correctness of an automatic speech recognition, it tends to be higher for lower classes across races. You can see here much higher in Wave2Vec. And also, across classes, and also actually across races. So for a system that's a kind of system that is already, if you think about the popularity of something like Alexa or using things on your phone, I think even a lot of the helplines on the phone now are using these sorts of things. We're looking at a system that is probably affecting already marginalized people. But we can also look, wrong button. When we look at the perplexity as well. So perplexity is a bit of a fuzzy metric in terms of what does it mean for perplexity to be at 300. But what we do know is that very high, like higher perplexities are correlated with more incorrect answers. So when you prompt a model, if your prompt has higher perplexity, it's less likely to give you the correct answer. And what we see here is that, once again, perplexity is much higher for lower class than upper middle class. So in the paper, you can see all of them, but for clarity here, I kept it just to the 2. And also it's much higher for Black speakers than it is for white speakers. So potentially this could have a huge impact on the hundreds of millions of users of language models like ChatGPT, for example. So there's a question of what we can do about it. So again, if you want to read more, the paper is now on archive. You can see all of the results by breakdown. You can find out all of the TV shows that we used. And what I wanted to say here mainly is that what I hope you've seen from these 2 is that bias is not only an NLP problem. And so it's what we call a socio-technical problem, which means it involves not only many disciplines, but it's coming from our society, right? These models are trained on our data. And so we need to think about how we're interacting with those systems and maybe look at literature from HCI or bring in collaborators from there to understand it. Of course, we want to think about ethics, right? What makes it right or wrong? Maybe in some cases it's okay. What are the moral issues here? And of course, the social sciences that are helping us to understand the society in which we live in that our models are learning. So it's a hard problem. The two projects that I just described, one of them we're working with a philosopher of emotions, for example, and it was her that brought to our attention that, hey, you might want to find out about these kinds of biases that we have. And similarly for the social class, you need to understand the society that you live in to be able to understand the problems that you might have. And so models, maybe it's a little harsh, but I think they're inherently deficient, right? You are simplifying the world. You are making some assumptions. And I think we are not always clear on the assumptions that we are making when we create these models. So what this says to me is that these stereotypes, it's not that they're an exception that the model happens to be picking up. We're building models to be general. And so they're really quite the norm in the data. And while curating the right data is really key, it's not the only issue, right? So the model that you choose, how you filter your data, remember going from 45 terabytes to 570 gigabytes. It's important thinking about if you're scraping Reddit, maybe which subreddits you are looking at, right? And so if you're looking at building classifiers and stuff, you can have a look at the survey that I linked, which is really nice, very thorough about all the sources of bias and mitigation strategies for this sort of thing. For mitigating bias in large language models, it's a very active area of research, but it's not going great so far. So it's so deep-rooted, right? We're talking about really such an enormous data that is not going to change overnight, even if we all of a sudden become super equal as humans. And so right now there are a lot of alignment methods, like people are working on, let's say, the reinforcement learning from human feedback. What happens with these methods is that we end up with exaggerated safety, where the model ends up refusing to answer very, perfectly harmless prompts, and essentially they're much less useful, right? So there's this sort of tension between safety and usefulness. And so in the meantime, for anybody creating models, the important thing is to very clearly document the data collection, the cleaning, and all parts of your model development. You should be very transparent about the use of large language models. I don't think it's a problem that we're using them as long as we are very clear. And to say that in the first step, really think about the assumptions that you're making when you create a model. And to be cautious, because the models are not perfect, right? They have many, many issues. But ultimately, these large language models are telling us about who we are and reflecting our own society. So to answer Pietro, when we're thinking about where the real danger with AI comes from, it's really us. So if you want to know a little bit more about our work, but more about NLP and emotions, AI and sexual harassment, that was my PhD thesis. What makes AI seem human, and should AI seem human, right? Anthropomorphism, or the question of empathy and AI. You can have a look. I see some people taking pictures, but I'll end here. So thank you very much, and I'll take any questions.
Thank you very much, Amanda. Okay, let's start with a question. Thank you.
Hi, thank you. Hi, everyone. Thank you for this great speech. Very, very interesting. I have a question. Maybe it's very simple, but what, in your opinion, if very personal, what do you think is best? If you have to choose between, for example, Gemini, where, for example, people ask for about picture of the Pope and you show a black girl, or for example GPT, where you show us that it's very it has some bias and something like that. So do you think it's, of course, the best thing is to just to fix and go into the middle, but is it better to how far are we willing, or do you think are we willing to go from reality? Because of course, as you said, the models reflect the society. So of course we would like society without bias, but it's something that it's not real at the moment. So what do you think is the trade-off, and what do you think should we we do? I mean, it's better Gemini with their approach, which is maybe it's bias free, but it's very far from reality, for example, or it's better like to be stuck with GPT and its problems. Thank you.
So I think it really depends on your use case, right? Part of it is that you can use these models to study, right? Do you want it to reflect the world as it is? Then you maybe want the model that is biased, right? And that goes for academic research or any kind of research where you're trying to understand the society that you live in now. Or do you want to kind of like think outside the box a little bit, right? So I think you don't have to choose one model and like marry it, and that's the one, right? But understanding what each model is bringing to the table, I think that's the thing that should guide your decision there, right? So yeah, I don't think we have to think about, there should only be one best model. We can instead think that different models have different capabilities, and you should know which one is the one that you need for your specific use case.
Okay, who's next?
Thank you for the talk, Amanda. I have a curiosity that was born after the talk of Corrado and your talk. I mean, you talk about the fact that social networks like Reddit and Twitter now are basically closed and you need a license to download the data. You talk about the dimension of GPT dataset, 45 terabytes. So I wonder in the future, especially maybe for small companies that do not have so much money to pay the license, what is the risk? How do you evaluate the risk that the next models will be trained on fake news, wrong information, and they will become stupid instead of more? Because I see from one side the technology is going better and better every day. From the other side, the data availability is going down because companies now understand that they can make money with the data. So I see a risk in this sense. I don't know, how do you evaluate? How do you think this risk is? How do you evaluate?
So I think I read in a paper recently that in only a couple of years, the majority of online data is actually going to be generated. So yes, you certainly have this problem of like now the models are going to be learning from models. And so part of me is very curious about the kind of word salad that's going to come out of the models when they're just trained on their own word salad over and over again. I think there are like a couple of points that you touched on. One is, smaller companies that don't have the budget. How are you ever going to hope to even compete or tackle companies like OpenAI? I think maybe this is where regulation is going to come in, because right now I don't see an easy way to do it when, like you said, companies like X, formerly known as Twitter, or Reddit are closing their things. Maybe we'll get back into building a lot of scrapers and just...
Which models are trained on model prediction? I see very risky.
Yeah, I think it's already happening, right? So there's a lot of papers now using models as annotators. And that's one of the things that people might be using these large language models for, with, for example, the emotion attribution is already to even label data that you can then, for whatever reason, train another model on, or even run other studies on and try to make research through models that are this flawed. So I see your problem. I am sorry, the point that you're making, I'm not sure without regulation seriously stepping in, and the idea that we have to find a way to label which data was machine generated, and therefore probably we should not want to model so much. It would be kind of pointless. Then yes, but I am quite the regulation advocate. So
okay, Andrea.
Thank you for your talk. Can open source help to solve the bias and bias problems, like open source models, open source, techniques, and what your thought about?
So I have a very pessimistic view of what's going to help with bias. We actually, we know that open source models like Llama, for example, it's not really any less biased than other models. Actually, some of the most horrible examples we found of sexism and emotions was from Llama. I think as a community, there was also, I don't know if you've heard about the whole 8 super hot ... all the models. There's like quite the telenovela, but basically trying to remove the safety things in models for less than some savory reasons, and that's all the open source community that's leading it, right? Not away from bias, but rather towards it in a more particularly misogynistic way. So I'm not super hopeful. I think that the open source community can help a lot and make a big impact in this sort of thing. But I think also the bias is just so deep rooted that I don't see a bright future for completely unbiased models. Also, what does it mean, right? Because it's such a complex issue. There are so many things at stake and to consider that. Sorry, it's not a great answer, but.
And what's the saying about a pessimist that is an optimist that knows something more about things? So, who's next? We have time to think about the questions, so let's profit and enjoy. Thank you.
Thank you. I have 2 questions. First one is, how do you think in our tomorrow when we are actually Monday when we come back to the office, how can we there are some mitigation techniques or points of analysis in which you can think you can use actually at the moment right now that you have experienced. And another question is, what is the relation with anthropomorphism in the models? As for example, when I read the you understand it. I thought actually this could be better because I expecting a biased response from a human and a objective response from a machine. So if I start anthropomorphizing the machine, which is something I know is not good, but maybe it could help me to understand that it reflects this kind of bias. So do you think there is this kind of relationship or is not so the case?
Okay, so that's a very, very interesting question. So to the first point about how to, like, when you go back to the office on Monday, how can you start mitigating biases? I mean, it depends, but let's say that you're using one of these off-the-shelf language models. I think the main thing is going to be to experiment with your prompt. I mean, I'm assuming you're not doing any kind of like fine-tuning of these models. But like one of the things that we want to experiment next is suppose we ask the same model to attribute an emotion to the system, but to do it assuming that this is, let's say, a feminist man. What does that mean, right? And we haven't tested yet, so I don't even have like preliminary results to tease anybody with. But to think about that. But I think at the moment, none of the techniques that we have are going to be very helpful because they also decrease the performance of the model. So again, I think the main thing there is going to be aware of the things. When it comes to anthropomorphism, that's such an interesting point because I think you would think that it would work that way, that because I'm expecting a human to be biased, if I think of the AI as more human, that maybe I will expect it to also be biased and I can take things it says with a pinch of salt. It's not necessarily what we find. It's like the anthropomorphism makes you ascribe it more intelligence, right? So one of the key things about this is that so far the only thing that has spoken or used language has been another human. So we still have, and also anthropomorphism is something that we do, right? If you look at like a plug or something, you always see like 2 dots and a little thing in the middle. You think it's like a little face. We just do it like that. When it's language and it's interactive, we really want to ascribe it intelligence, and we don't think of somebody who is intelligent as somebody who is biased, right? I think, well, of course, it's not. It's a false notion, but it's the truth. We don't think that if somebody is intelligent, they're going to be misogynistic or something like that, right? And so, unfortunately, it doesn't work that way. We think, sure, it sure seems human-like, but only in the good ways. So we found no evidence that that's the case. Instead, we find that, actually, by making it more human-like, you are unfortunately encouraging people to over-rely and like really believe everything that it says, even like that bulls are attracted to the color red. So I hope that answers your question.
Okay, we have another question here.
Thank you for the presentation. So one comment is that, of course, these models in the end are biased because the world is biased. So we generate biased data and they learn from this. And the real solution would be to unbias the world rather than the model, right? Has everyone ever thought that in the end, if we try to develop unbiased model, maybe this can help to unbias the world a little bit? Or has someone thought to actively use unbiasing these models to try to make the world a little less biased?
I think that's the hope of most people working on bias. It certainly is my hope, right? The idea is that you're interacting with these systems, you are learning things from them, and sometimes you might not even realize some of the things you're learning from them. So, for example, for my PhD, I looked at, I don't know if you ever noticed that most digital assistants like Alexa, Siri, etc., they are female in their personas, right? This is it's stemming from a bias that we have that if you think of an assistant, picture an assistant in your head right now, it is almost certainly a young woman. And so that's why those systems are female. The thing is that then I looked at the responses that the systems would give to sexual harassment. And the idea there is that they seem kind of accepting, right, of this harassment. So you might think that if you have enough interactions with these, so particularly, say, children, you might learn that this sort of thing is more okay than others. Like some of the systems, now they've changed it, but they used to like kind of flirt with you. I remember, was it Siri or Alexa that if you said, "What are you wearing?" It would say, "In the cloud, no one knows what you're wearing," which is extremely suggestive and really quite inappropriate in the social role that these systems are supposed to be performing. So, yeah, I think we had...
Okay, we have time for a few more questions. If somebody wants to book it. Okay.
So thank you for the super interesting talk. And I was particularly interested in the analysis of performance of LLMs with respect to the socioeconomic class, which was something that I've never heard about. Super interesting. I was wondering if there is if you have any insight. I will read the paper, I promise. But if you have any insight that you can share about which kind of error are made in what is the difference in the errors that are being made, at least, since that can have an impact on people's lives, right? So
So that's my next next step in the research. We just finished this one. It's been quite a ride. Like, I want to validate that this makes sense, right? So we know that it makes sense because there's another paper showing that the prompt is wrong, right? But I see as the possible of wrong answers in sort of two ways. Wrong answers that sound coherent but are giving you false information, or wrong answers that it maybe will refuse to answer. It gives you and maybe if this happens out of frustration, you stop using the system, which could disadvantage you, right? Already in a society where everybody's using these models. And obviously, if it's giving you false information, that's very serious. So that's sort of the next step I want to look at. And also thinking, of course, about how to mitigate this thing. Like, there's a lot of work now also trying to get large language models into education. If these models cannot understand or give wrong answers to people in disadvantaged communities, it's obviously going to be very serious. So if you want to talk about collaborating, we can over lunch. Any more questions?
Yeah, here. Thank you so much for your talk. It was very interesting. I think maybe like many, I've learned about bias from the book Thinking Fast and Slow. So this theory of two minds. And I was wondering to ask you if you think like something like that theories of these two minds can maybe help in this regard. Because as we were also trying earlier to find mitigation strategies, what the getaway that I get from that book is like, okay, I need to be conscious that I am biased and sort of like I cannot really eradicate the bias, but maybe I can try to understand where the bias is coming from, maybe one of the two minds, and then try to counterbalance with another. So my question here is like, do you see research trying to push where, for instance, nowadays we are fascinated with large language models that works in a sort of like a holistic way and try to rebalance with more symbolic reasoners or like a logic derivation proof theorems? Do you see like a research is trying to push in this direction, or is something that is sort of like not proven to be effective? Thank you.
So I have seen some research that is trying to do that, and certainly a lot of people that are trying to go that way. Also, in terms of the like moral values. So I don't know if you've seen this. There's a lot of talk about the moral values that these systems hold or have or reflect. Let's try not to use anthropomorphic language. But so far, I haven't seen anybody do it successfully. But you might be able to use a strategy like that even now as a much simpler thing. Like, let's say you remind the model that you should be a great sage who is not biased and see how that changes the outputs, right? Like, I think this persona capability can take us much further than we think. Because at the end of the day, there's also, one of my colleagues has a really cool paper where they take a lot of these models through the political compass. I don't know if you're familiar with it, but essentially it places you in some kind of spectrum from libertarian to authoritarian and left to right, the other way around. And this is something that a lot of people have used for these models. But what my colleague has shown is, Paul Rutger, if you're curious, they actually show that if you prompt the models multiple times, they change their mind a lot, to the point where you take, let's say, ChatGPT through the test once and then another time, and there's a bigger difference between where those 2 points will land than there is, say, between Trump and Biden right now, which partly says something about American politics, but certainly says a lot about what it means for these models to have values when the differences are so huge. And so really the way you're asking the prompt makes a much bigger impact than maybe we might want it to, right? We know they're super sensitive to exact phrasings, etc. But I think that's a really nice suggestion, and hopefully we see more research in that direction, because I think that's probably the way to like ground them into something real, let's say.
Okay. Thank you again, Amanda.
Feedback.
Escape from this. This is not bias or something like that. This is interact. some ways. So thanks again, Amanda, for the great presentation and the Q&A. I remind you that speakers are here, so if you have more questions, you can reach out to them. I'll also remind you that there are interviews published of the speakers on YouTube ArgoVision channel. So that's one of the reasons why, well, I didn't have time, but I also made some questions. It's really, really interesting, I think, this area, because especially dealt with so much rationality, it helps you a lot to try and think of the ways that you can do things to do better. So learning more is really great. And so let's give a round of applause to Amanda.
Thank you.
A couple of reminders. So again, I remind you about the survey, which I think it will be really, really easy this time, because we've had excellent talks. So you can just go ahead and give the top rating to everyone. That's my bias, at least. But of course, I participated in the selection of the speakers, so there's a bias again. Then more logistical things. So now we have finally the lunch. So there are 4 areas for lunch from the reception up until almost the lounge room. So you have to go back to where you came from. There are 4 areas which the same kind of food. So try to distribute and do not bias on the first one that you encounter. That's one thing. And then we reconvene at 2 in the lounge area for the lightning talks. And the people who have submitted lightning talks maybe come 5-10 minutes earlier just to test the talk or slides or whatever you have prepared, or even if you have no slides, just to say hi. So thanks everyone. I'll see you soon, and enjoy the lunch.